Hello, my dear students. I hope that all of you are fit and fine at your home. Today, I am going to take lecture on microgrid, which have been skipped in last lecture. Okay, let's start microgrid. By name, micro means small and grid means interconnection of network, interconnection between generating stations and loads. Means small form of the normal grid is known as microgrid. Let us discuss in detail. Okay. Contents under this slide will be introduction to microgrid, the need of microgrids, components of microgrids, microgrid operating modes, needs for ESS in microgrid. I will cover first four topics in this video and last topics from needs for ESS in microgrid I will cover in next video. Okay, let us see what is microgrid. As per definition, microgrid is a decentralized group of electricity sources and loads connected to microgrid. There is two words there, micro and macro. As by meaning of by words is micro is small, macro is large, means bizarre, right? Uh, Decentralized group of electricity sources. What is the meaning of this line? Decentralized, which is not centralized. Electricity source. Electricity source. There are a lot of electricity source. First one major electricity source is the thermal power plant. If we talk about renewable sources, that is solar plant and wind turbines, hydropower plants. And then this all the renewable energy sources is known as decentralized electricity source. And loads, as you know, loads are simply fans, bulbs, fridge, TV, motor, etc. When this decentralized group of electricity sources and loads are connected to a macrogrid, is known as microgrid. Okay? In other words, a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries that acts as a single controllable entity with respect to the grid. In a grid is a very big system of power system. It's involved all the large power plants, while microgrids involve the small power plants. They are distributed generations like solar plants or wind turbines or flywheels or battery storage, right? And microgrids enables local power plants generation for local loads. Another characteristic of this microgrid is it generates the power at local. It generates the power locally, means near to loads. For example, in your college, the all solar plants, roof solar power plants, which act as a microgrid. Means your that solar power plants established near the loads. while in normal grid or normal power system, the main thermal power plants, large thermal power plants, are situated very far away, right? And comprises of various small power generating sources that make it highly flexible and efficient. If there will be a large variety of sources like thermal as well as solar, wind turbine, battery storage, it makes highly flexible. Means highly flexible means if some of power plants, power sources fail, then other other will be come in action. And efficient, why it efficient? Because it's near to the load. There will be no losses in transportation of the electrical energy from generating station to load. Hence, there will be low losses. If losses will be decreased, this means efficiency will be increased. Hence, the microgrid systems is more efficient in comparison to a grid system or macro grid system, right? Let's consider the next topic. Introduction. Yeah, microgrid. It is connected to both the local generating units and utility grid, thus preventing the power outage. We will see the diagram. We can see microgrids is connected to local generating sources as well as utility. Utility means normally utility grids means the main power transmitting or distributing company is known as utility. This means our microgrid is connected to the local generating stations. It may be solar or wind turbine or battery storage, and as well as it's connected to the utility grid or main power system, due to which it prevents power outages. Because there are two possibilities. If main grid is failed, then the local generating station will feed the power. If the local generating station will fail, then utility grid will supply the power to the load. Excess power can be sold to the utility grid. If local power generating station or plants generate more power, then it can be fed into the main grid. Means it can be sold to the utility. Size of the microgrid may range from housing estate to municipal region. Size of the microgrid depends on the location. It may be simply housing estate means colony type load or municipal region. Municipal region like metropolitan cities, municipal regions, right? Key attributes of the microgrid. Attributes means simply inherent characteristics of the microgrid. Uh, Grouping of the interconnected loads and distributed energy resources. Distributed energy resources means it's also known as DG, means distributed generation. Distributed generation means the power plants which situated are connected near the load. First attribute is grouping of the interconnected loads and distributed resources. Means in microgrid, loads and distributed energy sources are interconnected, are grouped. Second one is can operate in Iceland mode. Iceland, do you know Iceland? Iceland means जैसे सुना होगा भूमि का वो टुकड़ा जो मेन लैंड से कनेक्टेड नहीं होता है, जैसे श्रीलंका एक आइसलैंड, लक्षद्वीप सुना होगा, लक्षद्वीप, अंडमान निकोबार or all these are known as Iceland. Similarly, in power system, uh, some some electrical system are will be known as Iceland when they are not connected to the main grid or main power system. Then we can say the attribute, second attribute is can operate in Iceland mode, means microgrid can be isolated from the main grid and it will be operated in well manner. Okay, the third attribute is act as a single controllable entity to the grid. Whole microgrid can be considered as a single entity. Entity means system or body. Microgrid can be considered as a single system uh, with respect to the grid. Okay. Next one is need of the micro. What is the need of microgrid? Microgrid would be the answer to our energy crisis. Yeah, do you know, as per growing population of the world and country, our present infrastructure for the power system is not sufficient. Uh, it's there is a lack of power or power generation in uh, like in comparison to the required power for the country or for the world both. Macro could be the answer to the uh, our energy crisis. Energy crisis can be minimized because there is a there is option of the DJ distributed energy resources, or there is option for the renewable energy generation like thermal, solar plants and wind turbine, etc. Uh, when we will use more solar energy, solar plants, it will reduce reduce energy crisis in present time, right? Second point is transmission losses get highly reduced. Transmission loss because the in microgrid, the energy resource distributed energy systems are situated or connected near the load, due to which I square R loss in transmission of the electrical energy get reduced due to get highly reduced. Yeah, it's because power generation in the microgrid is near to the load, almost almost half kilometers away from the loads, or less than half kilometer. Microgrid, third point is microgrid results in sustainable substantial savings and cuts emission without major changes to lifestyle. Right. Uh, Due to the microgrid, there is a lot of saving and it's reduced the emission. Emission means emission of carbon. As you know, in thermal power plants, we burn the coal and generate heat, and due to heat, we produce vapor of the water, and we drive the turbines. We drive the turbines, and turbines blade is connected to the armature of the synchronous generator or alternator, which produce the power in our main grid system or main thermal power plants. And if we use the distributed energy resources or renewable energy resources in microgrid, then there will be less use of the main grid, because renewable energy resources will supply to the microgrid. Hence, there will be less use of the main grid supply, and due to which there will be cuts in emission of the carbon without major change in lifestyles. Yeah, there will be no changes in lifestyle, right? fourth point is provide high quality and reliable energy supply to critical loads. Uh, because you know, when power transfer from a very long distance, there is a lot of switching devices are used, a lot of transformers used to step up and step down, due to which a lot of transients are unwanted frequency and voltage are involved in the good uh, power, due to which it's not good for our device appliances, home appliances like tubelights or TV, refrigerator or computer. Uh, since in case of microgrid, all the power plants, all the distributed DG, distributed generation are situated near the load. Hence, uh, there will be no chance to interrupt the frequency or voltage or current. Hence, the quality of the power will be very good and reliable energy supplied to the critical loads. And all sensitive load will be supplied by a good quality and reliable energy sources. Okay. Now the next slide is components of the microgrid. You can see here in this diagram. This is you can see that this is the wind turbine, wind plant, and this is the thermal power plants, and you can see this is the solar panels, and these are the loads. You are seeing like looking like village, and it may be considered a load. And you can see here the nuclear plants. You can say these loads will receive energy from solar panels, solar plants, other wind plants, and thermal plants and nuclear plants. Uh, More than one power sources will supply these loads, right? Distributed generation components of the microgrid. First one is distributed generation. Uh, Distributed generation, I have told you, well, it's example for distributed solar panels, wind turbine, and fuel cell or battery storage. Capacity of distributed generation will be less than 30 megawatt, right? And it will be connected near to the load. Second component of microgrid loads. Third component will be energy storage system. Yeah, energy storage system like battery, flywheels. These are the example of energy storage system. I will teach this topic in detail in next video. Static disconnect switch. Yeah, there is another component, static disconnect switch. Uh, Fifth component is controller, and sixth one is a mode switching device, and last component is point of common coupling or PCC. Okay, let us see in detail in next slide. This is the uh, schematic diagram for the microgrids. You can see this is the main utility grid, main power system or microgrids. And when the microgrids and connection points of the microgrids and the main utility grid is known as PCC, point of common coupling. This is the point of common coupling, right? This is a point again. This is the converter, and this converter feeds to the different loads. This is a compressed air system. This is a type of a storage system, energy storage system. Second energy storage system is a battery, right? This is a PV, renewable energy photovoltaic. PV stands for photovoltaic, or it's also known as the solar panel. Solar panel is electronically known as the photovoltaic cell, right? It will absorb the solar energy and generate the electrical power. right? The EV for electric vehicles. This is this will be considered a load, right? Flywheels. This is also example of the energy storage. DC coupled subsystem. This is a DC coupled subsystem. This is a computer, right? And this is a, I think this is a battery, right? And again, this is PV, WT, wind turbine, right? Electric vehicles. These are the example PV and WT. Photovoltaic and wind turbine will be considered as the renewable energy resources or distributed generation. Right? Hence, we can say that this is the schematic diagram of the microgrids, where uh, a small component of the power system, where where a lot of distributed energy resources are connected to the load, are also connected to the main utility grid. And this connection point where the main utility grid and all the loads, uh, small microgrids are connected, where this point is known as um, point of common coupling, right? I hope it's clear to everyone. uh, we can see uh, through electrical network, same diagram, microgrid operating modes. There are two modes of the operation of the microgrids. First one is island mode. Island modes means there will be no connection to the main utility grid, right? Utility grid is not supplying power. There will be no connection to the main utility grid. Static switches will open. Hence, the static switch will be open. You can see this is the static switch which connects all these systems of the microgrid. Feeder A, B, C are being supplied by microsources. If the utility will not supply, static switch will be open. Then then main utility will not supply to the loads of the microgrid. Hence, this feeder will be supplied by the local power resources or distributed generation. But feeder D will be one second. But feeder D will be isolated because it was static switch is associated here. When this will be disconnected, then this feeder D will be isolated, and it will be in dead mode. I hope it is clear to everyone. Very simple. When main utility grid will be disconnected by this static switch, this means this feeder will be isolated from this one. While this microgrid system was supplied by local distributed energy resources, hence there will be it will be work in island mode. Island means disconnected from the main utility grid, right? Now you can see this diagram in uh, real uh, diagram with energy storage, houses, and forest, buildings, etc. These are the loads. Uh, this is the energy storage system here, right? And this is the wind turbines, a renewable energy source. This is the substations, right? Yeah, main utility grids feed these microgrids. Natural gas generation. This is also a type of energy generation, right? This is energy storage system. This is solar panels, and you can say this is diagrams. This region is a region of microgrids, in which different types of energy sources provide the power to these loads, and this region is also connected to the main utility grids, right? Okay. Okay, this is all about the microgrids. If any queries uh, any of you have, you can ask in group. Thank you.